Hi Jay, how are you?
Hi, hello, Faizan, thank you.
I will hand it over to you to start with your talk on user-friendly video playback on the web. So over to you and all the best for your talk.
Hello, everyone, and good afternoon. Thanks for tuning in, and thanks to the organizers for having me. So, I'll be talking about playing and streaming videos on the internet, and in turn, playing videos inside your React application. Like today, if you had a React application and if you had to play videos on it, then how would you go about it? What's the state of the art? Do it. And of course, you want to do this while ensuring that the user experience is not affected. It's good. So when it comes to playing videos on the internet, the release and adoption of HTML5 was kind of a canonical event in its history because it brought native support for playing video inside the browser. So, so it might be hard to imagine now in 2024, but originally HTML web browsers and the internet by and large, they were not designed to transmit and play videos. The reasons for that are not hard to guess. Digital video was not common back in the day. Internet bandwidth was expensive, internet speeds were not as good as what we have now. So the result of that was that we did not have native video support for a long time until HTML5 came about. And up until that point, your only option to play videos inside a browser was proprietary tooling and solutions like Adobe Flash. So if you are old enough to remember the days of Adobe Flash, it used to be everywhere. It was all over the place. And that's how that's how videos used to be played. Now, there are a host of reasons due to which Adobe Flash had to die down. I won't go into those, but they were mainly related to security. So if we move on to the widespread release of HTML5, which was somewhere around the early 2010s, then that's when we finally got support for the native video tag. It's basically the video equivalent of the IMG tag. You give it a source and it plays the video out inside the browser without having to install anything else, right? So this representation here is a little bit oversimplified. If you were doing this and using this in production, it would there would be more things to take care of. So so the thing is, with the introduction of this, it simply meant that browsers were now able to play videos natively inside a web page, but we were still kind of left in the lurch when it came to transmission of large video files from the server to the client. So at this point, how things would work is that a browser would download your video file in its entirety and then begin playing it. So for large video files, that's obviously a problem because the user would have to wait for a significantly long time before the video can be seen playing. So basically what we needed was streaming, breaking down the video into chunks and delivering it one by one to the client. So so the question is, if can I do this? Can I achieve this natively without again having to install any third-party tooling, any proprietary solutions? So the answer to that, surprisingly, is yes. So the HTTP 1.1 specification has a thing called range requests, which is basically just a bunch of headers that allow the delivery of any resource in chunks. So any resource that you have on your system, it can be broken down into chunks and delivered to the client, where each chunk is delivered via one separate HTTP request. So if I wanted to today, if I want to stream videos on my web application on the web stack, then all I need is a bare bones HTTP server and an HTML5 compliant client, which are pretty easy to get. And most HTTP servers like Apache and Nginx, they have been supporting range requests for a long while, like since forever. There is one little catch here, though. The video file that you are serving, it does have to be in a stream-friendly format. So that's MP4 or WebM. Other formats like AVI, they are not suited for streaming. But even this is not a big ask because with the modern tooling and the video ecosystem that we have today, it's not difficult to get your video files in one of those two formats, MP4 or WebM. Right. So far, we have solved most of the problems that come with video streaming in a modern application, except one, and that's a big one. It's basically buffering. So buffering is, as a problem statement, it's pretty straightforward. The client is able to play out a chunk of video that it has right now faster than it is able to download the next one, right? So to address this, you basically need to bring the size of the video down, which you can do by which you can do in one of two ways. You can reduce the bit rate of a video. So a bit rate is simply it represents the amount of bandwidth a video takes up to store and transmit 1 second of its content. You can bring down the bit rate of a video. So then the video file will be of a smaller size, but it won't look as good. Or you can bring down the resolution of the video while keeping the quality high. So the video is smaller now, and I mean smaller in dimensions as well as smaller in its file size. So both of these solutions kind of work, but they are not the ideal situation to be in, because if you have a large number of clients, you will have clients with, very high resolution displays and great internet connections. So to them, the modified video will not look as good. And on the other end of the spectrum, you will have clients who are still using, um, poor internet connections. So to them, buffering would still be an issue. You can stream your video in a middle resolution, but it will still be an issue for a significant number of your users. So to address this, we have something called adaptive bitrate streaming. So it's nothing but a mechanism by which you do certain steps of processing on your original video. So let's say you have a video. The first thing you do is create multiple variations of that video. It could be different resolutions like here, or it could be different bit rates like earlier. And once you have these variations of your video, the next thing to do is split the video into multiple chunks where each chunk is a different file of its own. And these chunks are called segments. And apart from all these video files, you also need text-based a text-based indexing file which has information about all of the video segments that you have available with you to deliver. So I will do a quick demo now. Yeah, sorry. So so I have a web server set up on my local machine. It sends out a video file on this URL without supporting range requests like I talked about. So what the browser should do is download the entire video file and then start playing. So let's see if that happens here. Okay, so if we look at this, if we look at the video request here, what Chrome does is it does, it does not download the whole video file in one go. Somehow it manages to use one HTTP connection, TCP connection to buffer the video file in parts. This is entirely without range requests, and this is something that Chrome does on its own. Yeah, but if I switch the browser to Firefox, then it does what we expected any browser to do. It downloads the entire video file first, and then plays it out. So so I have the whole video up front, and then it begins playing it. So that was the dead simple variation of playing a video file on the internet. If we look at the version that involves ranged requests, then let's see what happens then in the network tab. Okay, so again, with the initial load, nothing really happens. Chrome simply downloads a thumbnail of the video so the user can see something. But now, if I click on the play button, it will start firing a bunch of requests. Each request is the response to each request is sized at 1 MB, and this size is something that I can tweak and configure on my backend. So that's another simple implementation where you have one MP4 or WebM video file and you stream it at this point without any third-party tooling, right? It's all native. any HTML5 compliant web browser will be able to play out this video and stream it in chunks. So now if we move on to this setup, adaptive bitrate streaming, again, I have it set up on my server and we'll take a look at that. Yeah, so again, Chrome did that thing. It simply downloaded a preview of the video. And now if I click on play, so we can see that it downloaded this version of the video, the 1080 pixel version, because it detected that the network on my device is good enough for that. Now, if I refresh the page and throttle my network a little, then let's see what happens. So the video buffered a little bit for a split second there, and then it intelligently switched to a lower quality, and we can see what it has switched to, which version of my video. It is the 360 pixel one. So depending on how your network behaves, the video player that you have, it takes these intelligent decisions on which segment to download next. Okay, so when it comes to ABS, to implement this in your web stack, you do need third-party tooling at this point. It does not have native support in the browser by default. So if we talk about the backend, on the backend, you need specialized tooling to, set this part up. You would have your original video and you would need that video converted into all these segments and a corresponding functional index file. And on the front end, you would need a custom video player that is able to parse this text-based file and assess all of these available segments and make those decisions on the fly. Yeah, that's actually it from my side. Thanks a lot.